All right. We are going to conduct an experiment today. Many students claim that they can taste the difference in colors of Skittles. Not just this one's different than that one, but they're like, ooh, that was a red Skittle. I know the taste of a red Skittle. Or yellow is my favorite and I could pick that flavor out anywhere. We are going to conduct an experiment and perform a significance test to see if you guys can actually taste the rainbow. So the way we're going to do this, I have a random sample of 5 Skittles. You guys are going to do this in pairs. We're going to have, I don't have blindfolds for everybody, so we're going to have to use the honor method. You got to close your eyes. So you're going to have to work with a partner. Close your eyes. The person doing the recording will come up and get the cup because the person doing the tasting should not see what's in the cup beforehand. All right? So we'll do this in 2 waves because you'll switch with your partner so that everybody gets to do this. First thing, so if you're the person tasting, you have your eyes closed, you'll reach into the cup, you'll pick up a Skittle, you got to show it to the person doing the recording so that they know what color it is. You'll put it in your mouth, and then you're going to say what color you think it is. The person doing the recording is going to record whether you got it right or wrong. Recorder, do not tell them if they got it right or wrong. We don't want people learning by doing the trials. Oh, it's actually the, no. The idea is to see if you already know what this is, all right? So hold it up so that the recorder can see, then put it in your mouth, say what color you think it is, and then we're going to repeat that. There are 5 Skittles in each cup, so you're going to do it 5 times. The recorder is only going to record the numbers of guesses that are correct. Once you're done with those 5 Skittles, then you're going to switch with your partner. The person that was doing the recording is now going to be the taster, and the person that was doing the tasting is now going to be the recorder. So the recorder, again, will be the person that comes up and gets a cup with the Skittles. All right? So I need everybody to pick out a partner. We've got 16 people in here today, so this is a perfect matchup. Decide who you're going to work with. All right, you guys working together? All right, are you guys working together? With other sets of partners. You guys working together? Okay. Parker, who do you want to work with here? You don't care? Who does not have a partner yet? Are you guys going to work together? Joan, who are you going to work with? Not sure? Want to work with Donnell? Okay. So that leaves this back table of 3. Who wants to work with Parker? Row. Okay. Come on and move up to the front. Decide who's going to be the recorder and who's going to be the taster. I did not touch the Skittles. I used the little cups to gather them out of the bag. So these have not been touched. Recorder, come up and get a cup. Taster, you are not allowed to look in the cup. You need to close your eyes. Taste it, and then if you need to spit it out, I'll give it another cup. I totally understand that one. Right. So we're just going after the flavor. Right. Close your eyes.
You don't tell me. Huh? You don't tell me. No.
Just record if it's right or wrong. Don't tell them if you got it right or wrong.
I'm very well.
I have to say one. Okay.
They're mixed together right now.
This one's definitely red.
So,
Yeah.
He
Definitely got that one.
with red.
Max, just flip your hand over.
There you go.
Yes, if you guys are all done, then you'll switch.
Oh, there's a yellow one, like.
Yellow.
Yeah.
Maybe I only like the sour Skittles. You should have done the sour Skittles.
Should have done sour skittles.
I would have.
Are you guys ready to switch?
Orange, I guess. I'm gonna get all of them.
Yeah. No green though.
I don't know.
It's not very good at it either.
Yeah, I don't need them.
You guys ready?
Just close your eyes.
Ready? Alright, were you doing the tasting?
Close your, keep your eyes closed. Just don't open it.
You guys are ready? Wonderful.
Boy, you gotta.
You guys ready? Yeah. Okay. Who did the taste?
Oh, did you see it?
Okay. Okay, try to look back.
Okay, that's it. Can we tell us how many they got? Right? No, that would be yellow.
What if they're all?
You're done. You got two right. You got the first two right. There was an orange, there was two reds, and yellow.
Alright. You got two of the bonds, so I get to eat skittles too.
Dude, there's no way. And we're just talking about
You drop one.
I think that's great.
You would have gotten that last one wrong too. If you get some right, you cheated. And the statistics messed
You
up.
got it?
Dang, I didn't even taste that. Is that purple?
That was a yellow.
You didn't drop that one, did we?
No.
Okay.
God, this one's
Are you guys all done?
You had 3 yellows and 2 oranges. You even guessed orange once. Is that purple? Well, the other one that you dropped was red. And then she gave you a yellow, and you guessed purple.
I don't need to feel about that.
I'll eat this out.
You guys done?
Yeah. I don't know, like the taste of Skittles is not like I wouldn't put it. They don't taste good on here. It's just sad taste.
Okay, is that it?
Chocolate is.
Yeah, that was,
Green hit the end.
So I would go green. You would.
Oh my god.
I really can't taste. You like yellow.
I know, I think I can only taste the very last
All right. So let's go through. First of all, how many total M&Ms were sampled? M&Ms. Skittles, thank you. 0 M&Ms. Sorry, somebody said M&Ms don't have a flavor, and I've had that in my head. That's okay, no worries. How many people are in the room? 16 people in the room. Everybody got 5 Skittles, so a total of? Total of 80 Skittles were sampled. All right, I need a volunteer with a calculator because we're going to figure out how many were right. I want somebody with Jenna and Aiden, will you be back up? Okay. So I'm going to go around the room. We're going to add up all the number of right guesses. So you had none? 0, 2, 3, 3, 1, 2, 1, 1, 3, 2, 1, 1, 2, 2, 2, and 2.
Yeah.
28. Oh, we need to take it down by 1. 27. No worries. All right, I'm going to do the state with you guys, and then working with your partner, I want you to walk through the rest of this 4-step process to calculate a significance test to see if we can taste the rainbow. So let's start off with our parameter. What's the name of our parameter? P. Oops. So P equals the true proportion of correct guesses, not for all students, but for all, what were we sampling? Skittles. The true proportion of correct guesses for all Skittles. What is our statistic then? If our parameter is P, our statistic is P hat. Yes. Do we have a value for P hat? Yes. P hat is what? 27 over 80. Let's get a decimal for that. 0.338. I'm telling you guys we're going to use a significance level of 5%, so 0.05. What are our hypotheses? What would the null hypothesis be, do you think? That you can or cannot? We're testing to see if you can. So my null hypothesis is going to be that you can't. If you cannot taste the rainbow, what would the true p-value be? What percentage would we expect you guys to get right just by sheer blind luck? How many flavors are there? 5 flavors. So just random assignment, we would guess 1/5. Like if you guessed red every single time, everybody in the room, we would assume that about 1/5 of them would be correct if you just guessed the same color every single time. Does that make sense? Okay. So what is my p-value as a decimal then? 0.2. The alternative hypothesis, this is what we're trying to find out. The null hypothesis is that, no, nobody's any good at this. Do you guys feel like you were excellent at tasting the rainbow? No. The alternative hypothesis is to see if you really can taste the rainbow. In that case, if you can taste the rainbow, what would we expect to be true about P? Is it going to be, we always have to do it back in relationship to our null. Do you think it would be greater than, less than, or just straight up not equal to?
If we could,
If you can taste the rainbow.
greater than.
Greater than. So our alternative hypothesis is that P is greater than 0.2.
So wait, what's our null hypothesis?
The null hypothesis is that you cannot taste the rainbow. So students are claiming they can taste the different colors. We're going to conduct an experiment to see if you can. So we're going to take the more skeptical approach, like, I don't think you're telling the truth. I don't think you can.
So your null hypothesis kind of like the opposite of what the comment?
The null hypothesis is, we usually look at this unless they state at the beginning. The null hypothesis here would be the more skeptical, right? If somebody is making this claim, you're like, well, you're going to have to show me that you can do better than just guessing red every time and getting 1 out of 5 right. Does that make sense? Okay. And we'll work a lot more with our hypotheses and how we know what the null is versus the alternative. All right. We got through the state together. I want you to work on plan, do, and conclude with your partner. We're going to take about 10 minutes for this.
The only reason
I just realized why I asked about it and taste test. I throw a bunch of them in my mouth at lunch. I don't know which is which. You as well. See you tomorrow.
Greater than or equal to? Or could be using 0.
I think it's 80 times the yeah, but if it is 16, then it will be way more.
Yeah. Oh, right.
Coming. What'd you say?
So, 80
So we're not doing our comp. We're gonna do our conclusion like we did yesterday. So are we gonna accept or we're gonna reject or fail to reject the null hypothesis? When we do a confidence, that's when we say we're 95% confident with it. So that we're comparing to our significance level or an alpha level. Yes. Yes. Very similar. Let me try to do it so I'm not misstating this.
Oh, it's the standardized test.
Yes. The general formula that we put out is standardized test. So the general will be standardized test statistic equals statistic minus standard over
Correct.
Yes, that's our general. And then our specific is the formula we have down there, the p hat minus p over square root of. Does that make sense? Okay. You're welcome. Yes. So the general, do you mind putting figures over to you guys? The general is. So this is what you said. The general standardized test statistic equals the statistic minus the standard divided by the standard. And then that's your specific.
I missed eating Skittles.
Carolyn, where we are, we're on the page that has this, and we conducted an experiment in class to come up with these numbers. And then we did this part together, and we're working on the bottom part right here.
It's just coming in like that.
Really? Okay.
We got lost when it came to do.
Okay, so this is what we did when we were doing an interval. What we're doing here, do you mind flipping your page over? We're going to look at yesterday. So the standardized test statistic, which is the z-score. So standardized test statistic equals the statistic minus the parameter divided by the standard deviation. That's our general.
Oh,
This is the specific for an interval. We weren't doing an interval on this one. Good questions, though. I like these questions. So then our specific formula is going to be this right here. Does that make sense? Okay. I want to make sure that we have enough time to go through this. We're going to have to finish up the backside tomorrow. But the name of the procedure, how many samples did we take? 1. So this is a 1 sample. Close. Are we calculating an interval for this one? No, we're doing a hypothesis test. So this is a one sample Z test. For what? For P. One sample Z test for P. Conditions. Is this random? Yes. I hope you guys trust me. I did just open the bag and kind of dump them in until there were 5. This was a random sample. So random sample of Skittles. I'm going to write this off to the side because I don't have a lot of room. Why do we do that? Why do we care about that? So we can generalize to what? What is our population? All Skittles, because we were testing Skittles here. This is so we can generalize to all Skittles. I realize Skittles have many different varieties. We've got wild berry, we've got sour. We're not generalizing to that. We're generalizing to all regular Skittles. What's another condition we need to check? 10%. So n is less than or equal to 1/10 of capital N. Thank you, Marquez. What was little n here? 80. Sorry, sir. So 80 is less than or equal to 1/10 of, what does big N stand for? All Skittles or all regular Skittles, yes. Which means there has to be at least how many Skittles in the world? 800. Did we meet that? Yes. So I'm going to check that off. I don't have the room to write that out, but we really should write out 800 is less than or equal to all regular Skittles. Why do we care about this? Why do we care about the 10% condition? Yes, we're checking for independence. So we can sample without replacement. Ran out of room. Last thing we need to check. Law of large counts. How did we do law of large counts? What did you use? We know our n is 80. What is p? What is p? 0.2. It's n times p when we have p. We only use p hat when we don't have even a guess at what p could be. So 80 times 0.20. What is 80 times 0.20? $80 times 0.20. 16. Greater than or equal to 10? Yep. And then we need to do 80 times 0.80. 64. Greater than or equal to 10. Yes. Why do we do this? Why do we care? Yes. This means that our sampling distribution of p hat is approximately normal. So far, so good? In the do, the general formula, standardized test statistic is equal to the statistic minus the parameter over the standard deviation. Snap a quick picture of this if you need to, because I'm going to go on to the next screen. All right. General formula, standardized test statistic and this is what we were doing over the last couple of days. We just didn't necessarily write it down like this. Standardized test statistic is equal to our statistic minus the parameter divided by the standard deviation. What is the standardized test statistic? That's our z-score. So z is equal to p hat is our statistic minus p, that's our parameter, over the square root of p times 1 minus p over n. Please make sure here use p, not p hat. All right, so let's calculate this. For the work, I have z equals, what was our p hat? 0.338 minus p, 0.20, 0.20, over the square root of 0.2 times 0.8 over 80. We're going to round this out to 2 decimal places. .338 minus 0.2, so that would be what, 0.138 over, I think on the bottom I got 0.002, is that right? How much? 6.17. I thought I got, did I do this right? Oh wait, I forgot to do the square root of 0.002. My bad. That's just what I got before I did the square root. What is our standard deviation? 0.2 times 0.8 divided by 80 and then square root that. I got 0.0447 on the denominator after you square root it. So I got 3.09 when I rounded that to 2 decimal places. Right. Quick question before we go. If it's 3 standard deviations away, is it very likely? No. We'll talk tomorrow about exactly what that is. We'll draw our picture and we'll do our conclusion, then we'll do the backside. Have a great one, everybody. I'll see you tomorrow. Boy, was ist das? Modern Containers. That's going to be Friday.